Hello viewers, this is Ronald taking you through today's tutorial on further integration. And in today's lesson we shall talk about integration by changing the variable. So this method is used to integrate a product or quotient of two polynomials in the form int k gx fx raised to the power n with respect to x, or a quotient in the form k gx divided by fx raised to the power n. Now then consider that this one is somehow different from the one for recognizing presence of a function and its derivative. For function and its derivative, the function outside was supposed to be the derivative of the one inside this bracket with the power. But in this case, whether this one is the derivative of this or it is not, we still use change of variable. In other words, this method of changing variable engulfs the method of recognizing function and its derivative. So all integrals which can be integrated using function and its derivative can also be integrated using this method of changing variable. So let's see the steps taken to solve such integrals. Step 1. Let the function inside the bracket with the power to be equal to another variable, say u. In other words, now this is the one inside the bracket, you will say u is equal to fx. So step 2 says that differentiate u with respect to x and then make dx the subject. So du dx, remember u was fx, so du dx will become f prime x. Out of that we make dx the subject to come up with dx equal to du over f prime x. Step 3 is to substitute for dx in the given integral. For example, if the integral was the product, then you substitute for this dx to come up with this integral. If it was a quotient, you do the same, substitute for dx to come up with such an integral. So at this step, the integral has been simplified and can thus be integrated easily but with respect to u, not x. So you have to note that. First notice that we use u equal to fx only if the power n on fx is an integer. So always note that. If this power is an integer, we shall use u equal to fx. If the power is not an integer, we take the whole of it with its power. Note 2 is that for definite integrals, values of the limits should be changed from the given variable x to the new variable u. We shall see how this is done in the given examples. So case 1, we shall start with integrals in the form k gx fx power n dx, where n is an integer. Remember, when n is an integer, we let u to be this. If it's not an integer, we let the whole of this to be u. So let's start with the case where n is an integer. In that case, we shall say u is equal to fx. And we shall start with this problem. Find the integral of 2x in brackets 3x squared plus 2 raised to the power 4 with respect to x. So since the power is an integer, we shall let what is in bracket to be equal to u. So we shall say let u be equal to 3x squared plus 2. Now that we shall differentiate. When I differentiate this, I'll come up with 6x, and after differentiating, I'll make dx the subject to come up with dx equal to 1 over 6x du. And with that, I'll have to substitute in my given integral. Where there was dx, I'll put there 1 over 6 times du, which is this. And I think I can realize that in this case, 2 and 6, this 2 will reduce 6 to become 3. This x will go with this, and you remain with u to the power 4 over 3 du. So shall remain with 1 over 3 u to the power 4, and that's what we are going to integrate. 1 over 3 is a constant, so pull it out and we are interested in integrating u to power 5. I think you can see that after substituting for dx, the integral that results is easily integrated. So that's what they meant. So in this case, we shall increase the power by 1 and reduce and divide by the new power. So this is the constant is here. After that, we shall say increase the power by 1, which gives you u to power 5. Then divide by the new power to get this denominator of 5. When I multiply this and this, I'll come up with 1 over 15 u to power 5 plus c. So always don't forget the constant of integration. But remember, the u, we are the ones who introduced u, so you have to again eliminate it by remembering that u is equal to 3x squared plus 2. Therefore, where there is u, come and put 3x squared plus 2. You'll come up with your integral being equal to 1 over 15 in brackets 3x squared plus 2 raised to the power 5 plus c. Those who attempted lesson 1, I think you remember that this was the same integral we tried out, and we used the method of recognizing function and its derivative, and we got the same answer. So now we shall go to case 2. Case 2 involves integrals in the form of the product, but this time the power is not an integer. And I think remember that when the power is not an integer, we let u be equal to the whole function with its power. So problem 2 says evaluate integral from a half to 5 over 4 of 3x square root of 4x minus 1 integrated with respect to x. So in this case, we take the whole of this with its power to be equal to u. So let u be equal to 4x minus 1 raised to the power half. This power half is the same as a square root. So I want to integrate this. But before I integrate, I have to remember that when I make x the subject, I'll come up with x being equal to 1 over 4 in brackets. It will be u squared plus 1. So in this case, to integrate easily, I have to first square both sides so that I get u squared equal to 4x minus 1. Now that I will differentiate both sides with respect to x. If I differentiate this with respect to x, I'll come up with 2u du dx being equal to, when I differentiate this side with respect to x, I'll come up with 4. So in that case, when I make dx the subject, I'll come up with dx being equal to 1 over 2 u du. Next, because there were limits, these limits were in terms of x, so I have to change them to be in terms of u. Remember, I have my x equal to this. Therefore, when x is equal to 0.5, I can also come here and substitute 0.5 here. It will become 4 times 0.5 will give me 2, and 2 minus 1 will give me 1. So square root of 1 is 1. That is why I put here 1. Then when x is 1.25, I come and substitute here, and the value of u we shall get will be equal to 2. Now that I've got the limits and I've got dx, I'll come and substitute. Now I think you can see that now the limits have changed. Where there was a half, I've put there 1, and where there was 5 over 4, I've put there 2. But I've done that only if this has changes to du. So this was dx, implying that these values were x values, and now this is du, implying that these values must be values of u. Out of that, I know that 3 is here. Then x, remember we made x the subject, and x was equal to a quarter of u squared plus 1. So I come and substitute for x here. Then I also know that the whole of this is equal to u, so I come and substitute my u. Then I also have to substitute for dx. Remember, we got dx as a half u du. Now when I simplify further, I'll realize that this 4 and this 2 will give me 8 to come up with 3 over 8. Then this u and this u will give me u squared to come up with this u squared. Then this one will come here to get u squared in brackets u squared plus 1. du. When I simplify further by opening brackets here, I'll come up with u to the power 4 plus u squared. I think we have realized that when you substitute dx, we get an integral which can easily be integrated. So now I'll use this concept for integration. Increase the power by 1, divide by the new power. So this was u to the power 4. Increase the power by 1, I'll come up with u to the power 5. So the new power is 5. I'll divide by the new power, which is 5. That's where this 5 comes from. Then for this one, it was u squared. So increase the power by 1, I'll come up with u to the power 3. Divide by the new power, which is 3. Out of that, I can simplify. When I get the LCM, it will be 15. Then I can put it out, and I'll come up with 1 over 40 u cubed in brackets 3u squared plus 5. Next is to substitute the limits. I'll begin with the upper limit. When I substitute this upper limit, I'll come up with this bracket. And when I substitute this lower limit, I'll come up with this bracket. And when I use the calculator to evaluate all, I'll come up with 16 over 5, which can be reduced to 3 1/5. And that will be your answer. Now we shall go to case 3, whereby the integral is in the form of a quotient, but this time the power is an integer. So remember, when the power is an integer, we let u to be equal to fx. So problem 3 says that integrate from 0 to 1, 8x minus 8 over x plus 1 raised to the power 3 multiplied by x minus 3 raised to the power 3. So in this case, we shall first expand this in brackets. When I expand x plus 1 multiplied by x minus 3, I'll come up with x squared minus 2x minus 3. Then remember, this power was the same and it will affect both of them, so I put it outside here. So with that, I realize that now my u, this power is an integer, therefore my u will only be this fx which is inside the bracket. So I come and say let u be equal to x squared minus 2x minus 3. When I differentiate, I'll come up with du dx equal to 2x minus 2. And when I make dx the subject, I'll come up with dx being equal to du over 2 in brackets x minus 1. Now that I've got dx, I also have to get the limits. So remember, my u is equal to this. So when x is equal to 0, come and substitute 0 here to become 0 minus 3. So in the end, I'll get my u as negative 3. When x is 1, I'll come and substitute 1 here, it will become 1 minus 2 minus 3. So in the end, I'll come up with negative 4. Now that I've got the limits and the value of dx, I'll come and substitute. So here for 0, I'll replace it with negative 3. For 1, I'll replace it with negative 4. But that is done because now the integral has changed, with the variable with which we are integrating has changed. This was dx, meaning implying that these values were meant to be for x, and now this is du, implying that these values must be values of u. Now this 8 is here. Now this one, I'll first leave it because in my dx I have also x minus 1. So when I leave it there, I realize that it will easily cancel out. But for the one down, the whole of this in bracket is u. So I'll come and say u is equal to u raised to the power 3, which is that. Then my dx was equal to du over 2 in brackets x minus 1. So I've substituted, and the next is to simplify. When I simplify, this 8 divided by 2 will give me this 4. Then this x minus 1 will cancel with this x minus 1, and I remain with u cubed as my denominator here. I think I realize that now, after substituting for dx, the integral that results is easier to integrate. Now this one is the same as 4u to power negative 3. And when I integrate that, I'll come up with negative 2 over u squared. Now that I've got the integral, I'll have to substitute the limits. So the upper limit, begin with the upper limit of -4, substitute -4 here to come up with this bracket, substitute substitute the lower limit to come up with this. And when I use the calculator, I'll come up with this x value, and when I simplify further, I'll come up with 7/72, which is the required integral. So now we shall go to case 4 for quotients, but this time the power is not an integer. So you remember, when the power is not an integer, the whole function with this power is let to be equal to u. So we shall use that to go through problem 4. Problem 4 says that find the integral of x over square root of x minus 2 with respect to x, and hence evaluate integral of 3 to 6 of x divided by root of x minus 2 with respect to x. So in this case, the first, you realize that now this square root is the same as the power of a half. So that's what they have done here. And in that case, we shall let u to be equal to the whole of this with its power, x minus 2 raised to the power a half. And in that case, when I make x the subject, I'll come up with x being equal to u squared plus 2. To integrate this one easily, I have to first square both sides so that I can get u squared minus x minus 2. And when I differentiate both sides with respect to x, this side I'll get 2u du dx, and this side I'll get 1. When I make the x the subject, I'll come up with dx being equal to 2u du. Now that I've got dx, and now that I've got the value of dx, I'll come and substitute for my dx. Now I think you are realizing that this time we are not changing the limits, because they first told us to get this integral and hence evaluate with the limits. So you have to first get the value of the integral without limits. That is why we are not changing the limits. So my x, remember we made x a subject, so my x was u squared plus 2, so come and substitute for x. Then the whole of this was equal to u, come and substitute for it. Then dx was equal to 2u du. Now that I've substituted, the next thing is to simplify. I think I can realize that this u and this u can cancel. This 2 will remain, which is this, and this one also remain, which is that. Now from there, the next thing is to integrate. When I integrate u squared, I'll come up with u cubed over 3. And when I integrate 2, I'll come up with 2u. Don't forget the constant of integration. Now for this part, I got the LCM as 3. So 3 divided by 3, I'll get 1. 1 times this, I'll remain with u cubed. But 3 divided by 1, which is the denominator for this, is 3. Then 3 times 2u, I'll come up with 6u. In the end, when I pull this one outside, I'll come up with 2 over 3. Then also here, there's a common factor u. I'll pull it outside to get 2 over 3u. In brackets, I'll remain with u squared plus 6. Don't forget the constant of integration. But remember, the u, we are the ones who introduced the u, so you have to again eliminate it. So I have to remember that u is equal to square root of x minus 2. Now I'm going to come and substitute. I begin with 2 over 3, which is there. Now this u, I'll replace it with x minus 2 under root. Open brackets, open brackets. Now this u squared, when you square this u, you'll get x minus 2. This is the u squared x minus 2. It was plus 6, so put your plus 6 here. Then there is a constant of integration, don't forget it. Now next we'll be simplifying. This x minus 2 plus 6 becomes x plus 4, which is here. So in the end, so this is the value of the required integral, which is indefinite. Now let's go to the hence part. So for the hence part, we are told that evaluate 3 integral from 3 to 6 of this. So what I'll do, I already know this. I'll just put the same limits. Now here we're not using limits of u because this is an expression in terms of x, so we shall remain with the given limits of 3 to 6. Now next I'll have to substitute. When I substitute 6 wherever there is x, I'll come up with 10 square root of 4. How does it come about? First of all, this 2 over 3 is a constant, pull it out. Then when I put this 6 here, I'll come up with 10, which is this. And when I put this 6 here, I'll come up with 6 minus 2, which is 4, and it is this. When I substitute the lower limit, put the 3 here, I'll come up with 7. 3 plus 4 is 7, which is this. Then put the 3 here, I'll come up with 3 minus 1, which is 1. When I simplify further, I'll come up with this. Remember, square root of 4 is 2. This gives me 20. And square root of 1 is 1. So I'll get 20 minus 7 to give me 13, which is this. When I multiply, I'll come up with 26 over 3. And I can reduce it to 8 whole numbers, 2 over 3. It's now your turn to try the following problems. So that is problem 1. Compare answer with that. That is problem 2. Compare answer with that. That is problem 3. Compare answer with that. That is problem 4. Compare answer with that. And that is problem 5. Compare answer with that. So that has been our lesson for today. Thank you for watching, and please subscribe to my channel, Rowa e-learning platform. Thank you.